Today I have some free time to test a small toy that costs $3.25 each. The toy is supposed to be wired with 4 cables to Arduino Uno board so it can transmit stereo sound to FM receivers. The toy requires 3.3 volts, which is already available on the Uno board. The communication between the Uno and the KT is done using Inter-Integrated Circuit Protocol, or I2C. The I2C should have pull-up resistor at both ends so that the signal resembles square wave. For the Uno, pull-up is done by software, and for the KT it is done by on-board resistor at pin 13 and 14. The Uno acts as a master and the KT acts as a slave. If Uno wants to write 8-bit data to a particular register in the KT, it will send 3 bytes composing of 1. Address of the KT, 2. Register number in the KT, and 3. The data to be written. This slide shows start and stop condition, and this the ACK or the NAC condition, which is transmitted from the KT to the Uno to confirm good reception of each byte. The KT requires many kinds of information from the Uno in order to generate correct transmitting frequency. First, the user needs to write sketch, which is then converted into hex file and send it to the Uno, which then resends it to the KT. The manufacturer of the KT provides the library called FMTX, which can be downloaded from the internet to help the user to write simple sketch to set transmitting frequency. Inside the KT there are 18 registers whose data can be changed by the user. For example, changing register 1 and 2 will change transmitting frequency. Each register has a default value so that a lazy user does not need to write a complex sketch. In other words, just use the manufacturer library, and the KT will transmit 90.1 MHz, which is the default, as simple as that. Shown here on the left hand side is a simple sketch to set the KT to transmit Japanese FM band at 78 MHz. On the right hand side is a summary of the manufacturer library, which contains 15 subroutines. The user can write a sketch to call any of these subroutines to change the default value of the register that he wants. In this example, the simple sketch calls subroutine number 15 to set country and frequency to Japan at 78 MHz. In case you forget, the FM band in Japan covers 70 to 90 MHz, and this picture shows one such Japanese receiver. Now we will connect a short rigid wire antenna to pin 16 and use the default 90.1 MHz to sweep and see how the waveform looks like. Okay, the BS1415 at 5 volts with no antenna outputs larger RF signal than this KT module with an antenna. This is a bad news because the RF signal from the KT is too small to cover the entire house. So a 2-transistor RF amplifier is added as shown here. Preliminary test confirms that the small RF amplifier is working properly and it is outputting 90.1 MHz. So let's sweep the RF amplifier to maximize power output and minimize the harmonics. As a result, the RF transistors amplify the signal almost 500 times larger. It also surpasses that of the BS1415. Looks like this modification will now cover the entire house. Power consumption for the 2 transistors is almost 400 milliwatts.